Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sahira binti Muhammad Samsul and my supervisor is Dr. Muhammad Saifuddin bin Muhammad Azami. I'm presenting my video Outstanding Performance for my final year project, which is application of BioX-based heterojunction photocatalytic systems for bacteria inhibition. So let's get started now. For chapter 1, which is introduction, it consists of background, problem statement, research questions, general objectives, significance of study, and scope and limitations. So let's start with background first. Background. As we can see in the previous video, the background of this study highlighting the increasing concern over environmental pollution, particularly water pollution, which poses risk to human health. So, how to overcome these issues? To address these issues, the review emphasizes the importance of developing new materials to eliminate antimicrobial compounds. Thus, semiconductor-based photocatalysis, which is BioX, is identified as a promising approach for environmental remediation due to its operational simplicity and high efficiency in degrading pollutants. But why BioX? Okay, this is because BioX photocatalyst has shown potential in effectively disinfecting water by generating reactive oxygen species, or we call ROS, that can destroy bacterial cells. As we can see in both diagrams here, when BioX photocatalysts are exposed to sunlight, they generate electron-hole pairs. And then these photo-induced charge carriers react with water and oxygen molecules to produce ROS. Lastly, these ROS are highly reactive and can penetrate bacterial cells, damaging their cell walls and membranes. Moreover, the review highlights the synthesis of BioX, which are hydrolysis, precipitation, hydrothermal method, and lastly calcination. Next is factors affecting heterojunction photocatalytic activity. There are 7 factors, which are light source, pH, temperature, size of the photocatalyst, photocatalyst dosage, concentration of pollutant, and structure of bacterial cell. Nevertheless, there are few fundamental problems with bare BioX, like poor specific surface area, high likelihood of photogenerated excitant recombination, limited light harvesting efficiency, and lastly, absence of active sites for catalytic functions. Thus, in order to improve photocatalytic activity, a variety of techniques have been used, such as elemental doping with metals, nonmetals, and rare earth elementals, heterojunction construction, co-catalyst, as well as creating oxygen vacancies. Problem statement. The first problem is there is lack of research on what kinds of limitations might be imposed to the BioX-based heterojunction photocatalytic system. Second, there is not much research on the kinds of improvements to mitigate limitations on photocatalytic activity. Lastly, further research is needed to determine which types of BioX photocatalysts can enhance the efficiency in inhibiting bacteria. Research question. There are 5 research questions, which are: does the BioX-based heterojunction photocatalytic system have any limitations on its uses? Second, what kind of modifications can be done to improve the limitations on photocatalytic activities? Third, which types of BioX photocatalyst is the most effective in bacterial inhibition? Next, what are the optimal conditions for BioX-based heterojunction photocatalytic systems to exhibit maximum bacterial inhibition? Lastly, how can the stability and reusability of BioX-based heterojunction photocatalytic systems be improved for long-term bacterial inhibition? General objectives. The first objective is to investigate the limitations of heterojunction photocatalytic systems based on BioX for inhibiting the growth of bacteria. Second, to discuss the future improvements of BioX-based systems. And lastly, to discover which types of BioX is the most effective in bacteria inhibition. Significance of study. The first significance is efficient bacterial suppression. Second, minimal environmental impact. Third, cost effectiveness. And lastly, potential applications. Scopes and limitations. The scopes are including investigation of the limitations of heterojunction photocatalytic systems based on BioX for inhibiting bacterial growth. Second, discussion on the future improvements of BioX-based systems to enhance their efficiency in bacterial inhibition. Third, exploration of different types of BioX photocatalysts to determine the most effective in inhibiting bacteria. Moreover, review of the mechanisms of BioX in suppressing bacterial growth and the factors influencing the photocatalytic activities. Furthermore, analysis of the synthesis methods of BioX-based heterojunction photocatalytic systems for potential applications in bacterial inhibition. And lastly, evaluation of the significance of utilizing BioX in photocatalytic processes for bacterial inhibition. Last but not least, the limitations of this review is not addressing the long-term effects of BioX-based systems on bacterial inhibition or potential ecological impacts, which limiting the understanding of sustained efficiency and environmental consequences. Moreover, this review is specific to certain conditions or types of BioX photocatalysts, which limiting the generalizability of the results to broader applications. Lastly, this review is not addressing the latest advancements or technological developments in BioX-based photocatalytic systems, which impacting the relevance of the research. Here we come to the end of this video. That's all from me. Thank you for watching and Assalamualaikum.